like to hear more about what you have done on the 100 gigabit testbed.
Thanks, Raj. Good evening, everyone. So before I start, there's one thing I would like to point out, that throughout all the talks which we have gone throughout the day, one thing was pretty common, that the theme is about data, data distribution, data accessibility, and data representation. So in today's talk, I will talk about how the network aspect of the data, like how the data, the work we are doing at the Fermilab, the R&D work, network R&D work we are doing at Fermilab, the 100G infrastructure at Fermilab, and the results from the SNet testbed that we have experimenting with data movement from over the 100G network using different middleware and protocols. So Fermilab is not new to the data and data movement. Like, we have been supporting high energy physics community and other multidisciplinary communities like OSG, Exceed in the data movement. Just to give an idea about how much data we have moved over the past few years, like it started with almost 10 petabytes of data in 2001, ranging to 94 petabytes of data. And that's just the data that was written to tape. And today, mostly, most of the data comes from offsite. And we see a peak of almost 160 Gbps over the LAN traffic, and from the tapes to the local processing farms. LHC WAN traffic periodically peaks in and out of Fermilab at 20 to 30 Gbps. And so you see, I mean, so we have been dealing with data for over a long time. And we have been working with in different layers of network to make this data accessible. So right from the upper levels of the science code, tools and services, data management, network management, application I/O. We have diverse program of work that spans all these layers. We have been collaborating with different research organizations, universities, for like eCenter, LSG dashboard, 100G testbed. We are working with the SNet guys. They have provided such a wonderful facility, which we have been utilizing to test Grid FTP, Globus Online. I'll talk about this in my talk. So we have a broad range of activities, which are both internally and externally funded. So just to give you an idea about the top layers which we have been working on, the effort that's been going on, we have been providing, working for providing tools and services to enable users and applications to optimize the network, so that the users can actually transfer data faster. We've been collaborating with the OSG networking area for the deployment of the personas at 100G testbed, at 100G OSG, at almost 100 OSG sites, OSG facilities. There is a program of work in form of OSG dashboard and eCenter, which is involved in aggregating this network information of the data transfers that go along, and identifying the bottlenecks or identifying any debugging issues that could be helpful in making this easier. Then we have been there's a group that have been developing tools to monitor real-time 100G network traffic through multi-core architectures. We also propose integration with data management. So we have been, network information can be used in making the data management layer more network aware. And we call this project as CortexNet, and we have been working with different collaborators for this. So that was about the top layer. The bottom layer of the services, we have an application level R&D through the high throughput data program. Three major thrusts of this. One of them is it's on a 100G network for production used by CMS and Fermilab facilities. Then we are working on the 100G testbed to identify gaps in the data movement middleware, like Grid FTP, SRM, Globus Online, XRootD, Frontier Squid, NFS v4, and I will be talking about the results so far we have observed on the, using these protocols on the 100G testbed. Then at the OS level, we have R&D on multi-core aware data transfer middleware, like what can we do to optimize the network I/O for 40G and 100G environments. And there's a team that is working on integrating the local network infrastructure with the WAN circuit technologies. We call it as policy-driven configuration, ESCPS. So that was about the different layers of effort that we are different layers of network and protocols and services. So how is Fermilab connected to the outside world? We have a Nexus 7000 switch with a 100G module, and we plan to have a 100G testbed R&D within Fermilab, which will have a production-like environment for technology evaluation and experimentation at different levels, and testing of firmware upgrades and all those things. So this facility will be on the 100G link provided by the SNet, and this will be interfaced to the Nexus 7000 Nexus 7000 the 100G router. And as a part of this testbed facility, we plan to have the initial setup of 12 nodes with 10G links, and each of 8 cores and 16 GB RAM. It's a modest setup. And then there are 2 nodes with 40G Mellanox with 8 cores NVIDIA M2070 GPU. And to give a much more realistic testbed environment, we also plan to have several nodes behind the Catalyst 6509 systems, which will have a 1G interface link, so the users can actually try to test in an environment which is more cluster-like. So the current WAN capabilities outside, currently the Fermilab is connected to the outside world via the SHE-MAN, the Chicago MAN. We have 8 10G links, that out of which 5 of them supports CMS traffic. 2 of them are used for IP, normal routed IP, and there is a 10G link for backup redundancy and failover. In future, we will be migrating to the 100G link. This is just a diagram showing how we will be connected. The 5 links which I talked about here will be replaced by the 100G channel with 100G channel, which will carry have the circuit-based high-impact science data traffic going along through them. We plan to share this link for R&D activity with the production. The idea being that when CMS has shut down or when the data movement is not at peak, we can get more of this bandwidth for more of the R&D and test activity. So there will be also 3 channels for IP routed traffic and full geography, and then 1 10G link. So as I said, out of the 100G, we plan to share 50G with the funnel with the CMS, and the rest 50G will be for the R&D. We are planning to have WAN circuit into SNet for 100G testbed. So this 50G link will be connected to a testbed facility locally I talked about, where we will be evaluating different protocols and grid middleware. So talking about the 100 goals of the 100G program at Fermilab, as you see, the scientific community it has been working with middleware, a stack of software layers and services to analyze and process the data. And we need to ensure that once we move the backbone from 200G, can the applications the data movement applications perform a scale up to the 100G scale? When we say that, okay, we are 100G link, that's fine, but can the tools and the services that are transferring data can drive the network to its full capacity? So in this, we are trying to understand and determine the tuning parameters and configuration at all layers to ensure that full throughput is obtained across each layer. and measure the inefficiencies that we observed as a part of end-to-end solutions when we do a transfer between one endpoint to the other endpoint. And anything which we find out, we want to monitor and feed this back to the developers so that they can rectify it. So to give an idea about the observations we had so far using grid FTP and different protocols over the 100G link. So if we started our work in this area in 2011, where we were working with the ANI, Long Island, the Lehman testbed, which was where we tested Globus Online and Grid FTP at over 30G links. In 2011 and 2012, we demonstrated that we can transfer CMS data between NERSC and Argonne using Grid FTP. We transferred almost 30 terabytes of data, and the peak we could observe was 75 GPS. We had to spend a lot of time trying to understand the best tuning parameters, what buffer size to use, what the streams to use based on different sizes of file, different characteristics, all these characteristics. So in 2012 and 13, the current program of work, we have been working on the SNet 100G testbed, trying to determine the best possible tuning parameters for the middleware for data movement. We have been working with XRootD, Grid FTP, SRM, Globus Online, Squid, and so far we observed that in our ad hoc tests, we could achieve up to 97 Gbps bandwidth utilization, peak speed. So, and I mean, the SNet guys have been very helpful in that, and they've been like, it's been a rapid turnaround time on the testbed thanks to their custom boot images. So we have scheduled slots during our test time, and we get as much as possible out of this 100G testbed. So in spring 2003, we hope that the endpoint at the Fermilab will be connected and be part of the testbed. We had to validate the link with transfer applications for CMS current data sets. And we have been working to test NFS. We are still in the process, and we have some preliminary results about its performance over the 100G testbed and DCAS. So this is the work which we have been doing with the collaboration, in collaboration with IBM. So to give some more details about the test results we have observed so far, an idea about how the performance of the transfers vary based on the file sizes. We had files ranging from 8 kilobytes to 8 GB in size, and we split the files into 3 major data sets. The data sets ranging from 8 kilobytes to 4 megabytes of file sizes. The small files, medium files ranging from 8 MB to 1 GB files, and the large files, 2 GB to 8 GB files. All the files in the data sets were the powers of, we increased the powers of 2. So one thing we observed is actually these are one of the latest results, and we haven't finished evaluating all of them. As you can see, the Globus Online test results are not completed in this. There's an interesting history behind it. I'll briefly mention this. So for small files, we observe that so far with pipelining and without pipelining, we get close to 30 Gbps. We are still evaluating and trying to understand what's the best way of using the pipelining for the small files and how it performs as the sizes of the file increases. So as I mentioned, until last year when we were working on testing this, we were working closely with Raj and his group, trying to understand what's the best. And the best performance we could get until last year was close to 2 Gbps on a 100 Gbps link. And it was interesting that we wanted to try out and have results as close as possible to what the user community would see, with just enough set of parameters turned on so that that's what most of the applications use internally. So the artifact which we've, the test bed we have has the root file systems mounted over the network. And it was interesting that when we had the logging turned on, but for just barely enough, irrespective of that, for small files, because of the speed at which the files were transferred, it was continuously, the GridFTP was continuously trying to log to the file, put the messages into logs, and that actually impacted adversely the transfers. So when we realized that what was happening, we recently disabled logging, and from 2 Gbps, we actually got a jump of 30 Gbps. So that was probably a lesson to learn from our side, is be aware of your test bed thoroughly. So for small files, we see that for the medium file sizes, we see that the Globus for the GridFTP is close to 80 Gbps, and pretty much the same thing for SRM. In case, while testing SRM, we were using SRM connected, using GridFTP protocol to do the transfers. But when we are using SRMs, not always you get all the functionality which is supported by GridFTP, so you cannot use all the tuning parameters you could use. So that's why you can see the overhead of few Gbps when you do the transfers. With large files, we got in the range of upwards, like close to 90 Gbps during the transfers. However, compared to SRM and GridFTP, we see that the Globus Online transfers were not performing at the same scale. And one thing to note is the way test bed is set up. The test beds and the nodes are set up behind a firewall. And there is only one way to access the external links through the 1 Gbps 1 GB cards. So we had to, and this test bed is accessible through the VPN, which has a round trip time of close to 100 milliseconds. So we had to have a special setup to test Globus Online, where we had a forwarding node which was registered as the Globus endpoint, and we had set up a port forwarding mechanism so that the connections, incoming and outgoing connections for the control channel, were forwarded from this node in the Fermilab to the test bed. So although the data was transferred over the 100G link, the control was still that 1G link. So one thing which we observed was in the pipelining is GridFTP does not support pipelining outside the context of directory transfers, which was something which we hope GridFTP team will address soon. And as you can see from the plots that with like example of 2 GB files, like with 3 nodes and 16 streams per year, we could get to a point of 97 Gbps. XRD, we tried to keep the scenario same, try to do the data, try to perform the same level of transfers, trying to compare apples to apples as much as possible. But with XRD, the problem is we do not have control over all the client-server tuning parameters. Another challenge we observed in case of XRD is, particularly because of the test bed, is the limit on RAM disk we could use. Since we wanted to avoid disk-to-disk transfers and actually measure the bandwidth, measure the performance over the 100G link, how fast the data can be transferred by the protocol. So in case of GridFTP, it was relatively easy to test because GridFTP lets you test memory to memory, or just. So writing to dev null, we avoided most of the overhead by writing to dev null and not using the disk in this test. But since XRD does not support writing to dev null, the other alternative, the closest alternative, was using RAM disk. So this was another limitation because of how much space was available to us using RAM disk. So we did similar test for Squid and Frontier. Frontier is used by CMS. Which we mimic the LHC use case for large calibration data. CMS uses Frontier, which internally uses squids to distribute this calibration data across different sites. Configuration we had was we had a cache of 8 MB file on the squid. The clients were at the NERSC, and the servers were on the Argonne side. And we had data always in the RAM to avoid the disk latency. So in our results, we found that when core affinity were enabled, we could see a performance gain of up to close to 20%, respectively, compared to what we saw when the core affinity was disabled. And the best performance we got was with 9,000 clients. We almost got to 100 Gbps. So also one thing to note is that, or one we observed is that increasing the number of squid processes improved the performance. So that's what we were working on until last year. And this year, we have been focusing more on understanding and seeing how we can better the performance of transfers using for small files. What are the, we are trying to understand how we, how we can use pipelining in different ways, different tuning parameters, and using concurrency to optimize the transfers. So we are trying to compare bandwidth utilization with and without pipelining, trying to find out the characteristics of the transfers. So one issue which we so far found out is that whenever we have pipelining enabled, it interferes with the concurrency. If you have concurrency and pipelining, the performance actually degrades. So that was something which we need to work together to get to resolve this or address this. So we are also doing similar tests with NFS v4 and PNFS. This is in collaboration with IBM Research. And the test bed setup is we are using the same same setup, but right now we are focusing on connecting between one node to the other node, one node on the NUS side to the other node on the NUS side. So we are having like 40G connections. The disks are mounted using NFS over the 100G link. Right now we are just using the 40G of it. And then we are validating the Dcache implementation of NFS. And one thing we observe in this that in both cases, we can only saturate up to 50% of the link. So this is something which we are working on and identifying whether this is the max. Either this is the max we can get, or is there something else we can do to better this performance. So that's the left side of the graph is using the 4 10G links. The right side of the graph is using the 140G link. So there are a couple of machines on the test bed which have 40G cards. So here we could only get up to 25% of the utilization. So these are preliminary results. The work is still going on, and we are trying to identify the potential issues in this. So to summarize what I talked about, we have been working in the network area, which spans all the layers of communication. I'm primarily working with the HEP community and astrophysics community. I mean, they are the stakeholders that have been driving this work. We plan to have 100G testbed as a part of this activity, and then we also plan to redo some of this work, test, and validate the results. And I'd like to especially thank SNET for their testbed and all the support. I mean, it has been fundamental in providing this facility, performing all the middleware validation and testing.
Okay.
And we hope to have 100G link in spring. So we look forward to be part of this testbed soon. So with that, if there are any questions, I'm open to the questions.
Any questions for Parag? Here is Shreyas Cholia from NERSC. Shreyas works on science gateways and bringing all the HPC capabilities, making it easily accessible to users via web. Shreyas has put in place like a MyProxy-based solution to hide all the complexities of the certificates at NERSC, which served as one of the motivations for the Globus Connect multi-user. Today he's going to talk about how they're using Globus Online platform in Keybase.
Yeah, so can you guys hear me, or can you hear me now? Okay. I think the weather totally stole my show here, so. But yeah, I am Shreyas Cholia. Most of you know me from various roles at NERSC that I've had. But today I'm here to talk about a project that I'm working on with Keybase. So you heard a little bit about Keybase earlier. Ian mentioned it. Keybase is the DOE systems knowledge base. It is a bioinformatics, I don't want to say database because it's a lot more than that. It's a bioinformatics system that is meant to provide access to data and then modeling on top of that data. So you have this framework that's community-driven, where you can reconcile algorithms and data for systems biology and present it to users as web APIs, as client libraries, and as this platform that they can code against. So, in short, a framework. It's the Keybase project itself is a collaboration between various DOE labs and partner organizations. So it's LBL, Argonne, Brookhaven, and Oak Ridge are in the core mix, and then we've got partners at Cold Spring Harbor, UC Davis, Hope College, UIUC, Yale, University of Tennessee, and then we work with external partners at the JGI, EMSL, and various bioenergy centers. So the idea behind Keybase is that you have users who access data and tools through a command line client, through an API, or through a browser. All modes are permitted. And you upload data, you download data, you go through this tool, and then hopefully you'll come out of it with predictive models, hypotheses, visualizations, analysis. And so it's really kind of trying to take analytics and modeling to the next level in terms of bioinformatics and systems biology. And before anything else, I should say, just if this is all very confusing, go to www.keybase.us and check out what it's actually about. And they have a section called Keybase Labs where you can actually try out the various tools. And that might make this a little more tractable. So where I'm coming at this is Steve Chan and myself have been working on building their authentication and authorization infrastructure. And at one point there was thought of building their own, and that quickly sort of devolved into, do we really want to get into the business of building our own security infrastructure? And it turns out that for most of our use cases, Globus Nexus was actually a really good fit. And so most of this talk is just going to be centered around what the Keybase use cases are and how Globus Nexus basically solved that problem. So in case you don't know, Globus Nexus is the engine that does all of the security, the authentication and authorization behind Globus Online. I think, is that relatively accurate? So it provides things like access control groups and, of course, the actual login setup. So that's kind of what we wanted to leverage. So our use cases were, you want the user to be able to sign up for a Keybase account. From the command line, you want the user to be able to fire off a command and get back some credentials. You want the user to be able to use tools that can use a cached credential. And you want to be able to go through a web application and authenticate via the browser. You want to be able to do some sort of delegation where you have an access token, and then you want the web server to perform actions on behalf of that user as that user. And then you want to be able to do things like sharing data and sharing applications with other users who may or may not be Keybase users, and so different levels of access control. And did I miss anything? Well, we'll come back to it if we have to. So the first kind of obvious one was, well, we want someone to be able to log in, and I think the branded Globus Nexus service provided a fairly straightforward path to that. So kbase.us has a branded site. You go there, you log in, you sign up, and that sign up actually registers your account and sends an email to the KBase administrator saying, there's a new user signed up, and give them the appropriate access controls. So this is kind of the meat and potatoes of what we ended up doing, which is to build libraries around the KBase infrastructure to provide programmatic access to these credentials. So we ended up using the OAuth 2 client credential flow, which provides you with basic client-server authentication and bearer tokens. So what you do is you log into log into Globus Online via this Nexus REST API, and we actually went ahead, we took the Python client from the Nexus source code, and we reverse engineered a Perl client for that as well. So now you have all these internal KBase client libraries that support things like caching credentials, being able to log in with your SSH keys, being able to log in with your username and password, and then getting back an OAuth credential that can then be used by your tools. So here's kind of an example of how we would do this in Python. So it's just tapping into the Nexus REST API under the covers. All you're doing is saying, here's initialize your token, go out and make a request, here's my user ID, here's my key, and you get back a nice cryptic token. All right, so to kind of take it the next, so this was doing it from the command line. The next step was to, of course, do it from within the web browser. And we tried following a similar approach, and we quickly ran into what's basically the cross-site jail that your browser has. So it turns out that your browser can't actually, for very good security reasons, because you don't want random site X talking to your bank, your browser can't actually communicate across sites unless some certain things are in place. And this is, so we wanted to be able to log into Globus Online through a KBase site, and that's essentially a cross-site request. So it turns out there is a way of doing this, and HTML5 and the W3C have a specification called cores, so we're working with Globus Online to actually make that happen. But for now, to get around the cross-site issue, we actually had to stand up basically a proxy server that takes your requests within KBase and just relays them onto Globus Online. Hopefully, if we can get cores worked out, that won't be an issue anymore. The other use case was this idea of delegated access. So once you have a bearer token on your browser, pass it on to the web service, have that go and do something on the back end for you. We actually have only just started using that for a couple of use cases. It's not the most common use case, but I think that'll ramp up over time. And I think, again, one of the other ongoing discussions we're having there is to sort of transition to using JSON web tokens, which is a authorization token, but it's in JSON format that can then be serialized into base 64. So it's, if you don't have a lot of bytes to send your data across, the JSON web tokens are really nice because they just turn into base 64 and give you a lot more room to work with stuff. So the idea is, with this, we were able to set up a jQuery login widget that could go to this Globus Nexus site and then, or go to the KBase site, which on the back end goes to the Globus Nexus site. I can give you guys a demo, or you could just go there yourself, which is you click on go login dot, and I'm not sure what happened there. I'm not even going to bother. Uh-oh. Okay. So I don't know what, okay, so I'm not going to try this right now. Yeah, it's a little too, I can't get to XKCD from here, which is, so, all right. It's fine. I mean, it's just another, I'm just going to show you this. So I don't need to wrestle with security permissions. All right, so the other big thing that Nexus brings us is users who are, it gives us the idea, the notion of access control in groups. So when a user first logs in or signs up through the K-base skinned Globus Online, they get an account, but they don't have access to a lot of things. And then we can add groups, add people in groups to give them more sort of fine-grained access to specific parts of the infrastructure. So here's kind of that, a screenshot of the group management interface. So this is something that's visible to the manager of K-base, and they can, add and remove access controls from various users. And again, this is all just part of Globus Nexus, so we're just leveraging what they already have. So yeah, and part of this is it's been a negotiation. So K-base has been talking to Globus Online and been very responsive in terms of asking for, we've asked for specific features, they've put them in, particularly with the OAuth support. I think we've kind of been able to work together to come to something that works for us. So, and that negotiation continues. So we're looking at doing Globus Online group callbacks and for K-base internal permissions. So Globus Online has given us support for callbacks so that when there are changes to the members or creation of new groups within Globus Online, callback can be used to notify K-base that there's some update that needs to be pulled. So there are features that exist for this, but I think K-base has to integrate that into it, so there's some negotiation that has to happen there. I talked about the CORS thing earlier, so I think we're interested in seeing if we can do a legal cross-site authentication, essentially, so that we don't have to do this hop through the back end. And then the next step is, of course, actually starting to integrate with the core of what Globus Online is all about, which is their data transfer service. So we are talking, so K-base uses this thing that came out of MGRAST, which is called Shock, which is being used as their auxiliary store. So it is basically a file server and metadata catalog for those files that you can store stuff in. And we're talking about integrating the Globus Online transfer service with Shock so that you can move data on the back end using their REST API. And yeah, that's kind of it. I think we're working with Nexus has actually saved us a lot of headaches, and it's been, really great to work with these guys. So that's my spiel. And here's our obligatory DOE acknowledgement. Please visit the K-base site, www.kbase.us, and see what it's all about. And yeah, if you have any questions, let me know.
Any questions for Shreyas?
All right, thank you.